Section 5.4 is about unit rate, so we're going to be looking at some graphs and determining the unit rate. Remember that unit rate means something per one item. So let's take a look at the graph here that shows the results of a plant growing contest among 3 friends at a local plant club. The question is, which friend's plant grew the fastest, and explain how you know. So make sure that you understand the question is which one grew the fastest, not which one grew the tallest. So if we take a look at some points on the graph, I'm going to look at friend 1 first, and friend 1 starts here, and the plant obviously did not do very well. The plant died because after 2 weeks, the height of the plant is 0, so that means that it did not grow at all. So friend 1 is pretty much out. So let's take a look then at friend 2. Friend 2's plant starts here, and we're going to take a look at that point right there, which is the point 612. So that means after 6 weeks, the plant was 12 inches tall. But if we take a look at where it started at 6 inches tall. So that means that it grew 6 inches in 6 weeks. If we talk about its unit rate, that would mean we're looking at how fast it grows per week. So if it was 6 inches in 6 weeks, that means it grew 1 inch per week. So we would say that the unit rate is 1 inch per week. Now let's take a look at friend 3. So friend 3 starts here, and if we take a look at that point there, after 6 weeks, friend 3's plant is 10 inches tall. So 610 is a point, but again it started at 2 inches tall. So it grew 8 inches in 6 weeks. So if I want the unit rate, I would figure out how tall it grew each week. So I'm going to do 8 divided by 6, which is 4 divided by 3 if I use equivalent fractions. So that's 1 1/3 inch per week. So if I want to know which friend had a plant that grew the fastest, I would say it's friend 3 because of its unit rate. All right. Let's take a look at the next example. In the next example, the graph shows the amount of milk used to make a particular cheddar cheese. And the question is, how many ounces of cheese can you make per gallon of milk? So this key word here is per, and that is telling me we're looking for the unit rate. So when you're looking at the graph, ounces is the Y value, gallons is the X value, so the unit rate is the Y divided by the X. So all we have to do is find a point on the graph, and they were kind enough to point one out. So this is this is the point 232, So that means it was 32 ounces for 2 gallons of milk. So I would do 32 divided by 2, and that's 16 ounces per gallon. And notice how I'm putting a unit with every answer. So make sure that you realize that. Let's take a look at the next example. Your neighbor burns 88 calories in 8 minutes cross-country skiing. There is a proportional relationship between calories burned and time. What's the unit rate of calories per minute? So that means that since it's a proportional relationship, then if we take a look at this graph up here, this is proportional because it goes through the origin and it's a straight line. So this one is also a proportional relationship, and therefore we can find the unit rate by doing the y divided by the x. So calories per minute here is 88 calories over 8 minutes. So 88 calories over 8 minutes would equal 11 calories per minute, and that's the unit rate. Part B says to use the unit rate to draw a graph that models this situation. The horizontal axis shows time, and the vertical axis shows the total calories burned. And then they ask what the slope of that line is. So if we draw a set of axes here, the horizontal line, the horizontal axis is time, so I'm going to say minutes, and the vertical axis is calories. And then I need to put some numbers on here. Now the numbers, if I use the fact that it burns, or she burns 11 calories per minute, then that means after 1 minute you're going to burn 11 calories, so 111 is on the graph. After 2 minutes you burn 22 calories. After 3 minutes you burn 33 calories. After 4 minutes you burn 44 calories, and that relationship continues. After 0 minutes, we'll burn 0 calories, so 0, 0 is on my graph. So 111 is on the graph. 222 is on the graph. 333 is on the graph. And it would probably be best if I used graph paper to do this, but there is the relationship. And the slope of this line, remember, slope is rise over run. So I rise 11 and I run 1. So the slope is 11 over 1, which is 11. And you should notice now that the slope, 11, and the unit rate, 11, are the same. Let's take a look at the next one. This one says your friend borrows $200 from her parents, and the graph shows how much money she owes her parents. How much is she repaying her parents per week? How long will it take your friend to repay the loan? So if we take a look at the wording, how much is she repaying her parents per week? So that means we're looking for the unit rate. And if she starts off with, after 0 weeks, she owes her parents $200. And after 2 weeks, she owes her parents $160. If we take a look at that, so that means after 2 weeks, she has paid how much money. So she went from owing 200 to owing 160, so that means she paid $40. So if we're looking for how much she repays per week, you would take that 40 divided by 2, so $40 divided by 2 weeks, if I put the units in there, is equal to $20 per week. So that is the unit rate. She pays her parents $20 per week. And then I'm asked how long it will take to repay her loan. So normally I would just look at the graph when it hits the x-axis, but obviously I don't have my graph extend that far. So let's do a little calculation instead. So we know that she owed $200 and she pays $20 per week. So if we calculate it, we would do 200 divided by 20, and that would give us how many weeks it takes. So if we do $200 divided by $20, that gives us that gives us 10 weeks to pay off her loan. And those are the examples that I wanted to go through for section 5.4.